Hello friends, we will discuss the modes of operation of a BJT. As I said already in the previous class that if one diode, how many number of biasing techniques we can apply? For one diode, we can either apply the diode is in forward bias or reverse bias based on the terminals given to the regions. Assume a diode, it will be what P, this will be what N. For this P, if we give positive, for this N, if I give negative, then the diode is in what? Forward bias. Let us consider the same diode. Instead of giving plus to P region, if we give minus to P region and plus to N region, then the diode will be in reverse bias. Diode bias switch will be just on, just like this. For diode is in reverse bias, switch will be off, open circuit. Okay, this is the two basic conditions for one diode. One diode, how many biasing techniques you can apply? Forward bias or reverse bias. So we have two biasing techniques for one diode. As I said already, transistor means it is a sandwich of two diodes. Sandwich of two diodes. Yes or no? For example, if you see this circuit in this figure, this is figure 1. Let us consider this is what figure 2. In this figure 2, you exactly diagonalize this one. This is what NP, this is what PN. This emitter to base will be what? Diode 1 means. This base to collector will be what? Diode 2. How to represent this one? NP. N will be represented by this. P will be what? This one. Okay. In the same way, how to represent this PN? PN is like this. PN. This is nothing but the transistor. Okay. This collector is, this is what? Emitter terminal. The base point is nothing but the medial point is base. This terminal is called collector. Hope you understand this point. Okay, based on that, we have two diodes. Transistor will be a combination of two diodes. Two diodes means how many biasing techniques we can apply here? One diode, two combinations. Two diodes, how many combinations we can apply here? Four combinations. Hope you understand this point. Now we will discuss all those four modes here. Let us write here. Modes of operation of a BJT. Modes of operation of a BJT. Okay. So first of all, let us consider here mode, then followed by okay. So let me write here. Okay. In the first mode, what we will be writing here? Let us consider this is what cutoff mode. In the cutoff mode, how will be the emitter and collector junctions are? For example, if you see, this is what emitter to base. Emitter to base, we have one junction. This is called emitter junction. And also same way, from base to collector, we have one more junction. No, you can see this is what collector junction. emitter junction and collector junction. So let us name this as what? Emitter junction. This is what? Collector junction. Collector junction. If emitter junction is forward bias means how to connect this forward bias? N should be connected to negative, P should be connected to positive. Am I correct? Then this diode will be forward bias. For cutoff region, emitter junction should be in reverse bias. In the same way, collector junction should also be in reverse bias. Then the transistor will be in cutoff mode. Okay. During the cutoff mode, how the property of the transistor will be is it offers very high internal resistance. It offers very high internal resistance. High internal resistance. Offers high internal resistance means then the application where we use this cutoff mode of transistor will be we consider that application as an off switch. Okay. In the same way, that was the cutoff mode. Let us consider another mode is saturation mode. Saturation mode. During saturation mode, both the emitter and collector junction should be in forward bias. Then it offers the what type of property it will be offering? It offers very small internal resistance. Very small internal resistances. Then application will be it used as an on switch. During saturation region, during saturation mode, the transistor will be used as an application of on switch. Let us consider the another mode is active mode. Active mode of transistor. Active mode of transistor means emitter junction should be in forward bias. Emitter junction should be in forward bias, whereas collector junction should be in reverse bias. What is the property it will be? It will be used as an excellent transistor here. Excellent transistor. Transistor is denoted by Q. Then what is application during with this property is it acts as an amplifier. Acts as an amplifier. Next is if it is active means let us consider this opposite cases inactive or reverse active. Reverse active or inactive. Inactive means reverse active means you have to reverse this collector emitter junction biasing techniques. Instead of forward bias, it should be reverse bias, and this should be forward bias. And what is the property it will be offering here? It acts as a if it is excellent transistor means here it is poor transistor, and here if it is amplifier, it is amplifying the small signal to large signal means here it will be what attenuator opposite to amplifier. Attenuator. Hope you understand this point. Okay. Practically, BJT is not using attenuator. Okay. We generally use amplifier. Thank you.